Our project mainly focuses on the improving the quality of the thermal infrared images by using high-resolution optical images as guidance. This helps generate clearer and more detailed thermal images, which are useful in many real-world applications. Now I will briefly introduce the motivation behind our work. As we can see the introduction slide, there thermal infrared or TIR sensors are widely used in areas such as wildlife monitoring, urban heat island analysis, agriculture, surveillance, and environmental monitoring because they capture temperature information instead of visible light. However, the major limitation of the thermal cameras is that they produce low resolution images, typically between 5 to 10 meters per pixel. In contrast, optical cameras capture much sharper images with the finer, sharper details. Our project aims to combine the strengths of both sensors. We use high-resolution optical image to guide the super resolution of the thermal image. As a result, in the thermal image that is very spatially stable and thermal accurate. To achieve this, we address three key challenges. First, multi-sensor alignment. Second, thermal fidelity. Third, guided fusion. Our ultimate goal is to generate the high-resolution thermal maps that are both visually sharp and thermally reliable.
At first, we have to upload data. As data, we have to upload two images. Then it will be processed. Then it will select a method. Then it will run as SR. Then we can view our result. It will be evaluated as exported. The flowchart of our project is at first as input it will take high resolution optical image and low resolution thermal image. Then a registration will be done. Then a network will be guided. Then calculation will be done. After that it will be evaluated. After that we can see the output. This is our code. Here we have used as packages Streamlit, CV2, NumPy, PIL, and image. Using these packages, we have made this code. As output, we get this web app. Here is two options. Upload. At first, we have to upload low resolution thermal image, and then we have to upload high resolution optical image. Then we have to select this option, run super resolution. After that we can get the third image. I have uploaded this first black and white image as the low resolution thermal image. Then I have uploaded the color high resolution optical image, and by combining these we get this output which is shown on the third image.
To present the future scope and conclusion of our project. So future use one হচ্ছে urban planning. It can help in planning smart cities. It can monitor roads, buildings and cities areas. দুই হচ্ছে technical upgrades. In the future we can use a better AI models. This will improve speed, image quality. So, three, precious agriculture. It can help farmers check crop health and find the problems in crops at an early stage. And fourth, wildfire management. It can detect the forest fires early. It helps reduce the damage and save forests. These future applications so that our project can be useful in many real world fields. Next slide. Conclusion. In conclusion, our project successfully enhanced the resolution of thermal image using a lightweight CNN model while preserving thermal information. The results show the improved image quality and better performance, making the system suitable for practical applications in remote sensing, environmental monitoring, and disaster management.
Sir, this is our code. Now I am running it. After running, this screen is opened. Here we have to upload a low resolution thermal image. Here I am uploading this image, and here we have to upload high resolution optical image. I am uploading this image here. Now I am running super resolution. I have given this image at the first option, and then I have given this image at the second option. After after run as super resolution, this third image we get as output. So this is the output.
Very good. Carry on this work.